Hello and welcome to this ETSI webinar. My name is Gavin Craig and I'm the Senior Technical Content Officer at ETSI, and I will introduce today's webinar. This webinar has the title ETSI TeraFlowSDN Release 2 Features Overview. It will be presented by Ricard Vialta, Oscar Gonzalez de Dios, and Luis Gifre, all from TFS. It will offer an overview of the recently announced ETSI TeraFlowSDN Release 2, and also give a demonstration of some of its latest features. In this second TeraFlowSDN release, a big focus is put on scalability and resilience of the controller, with a complete redesign of the context component to include a scalable database, that is CrocoachDB, to support the stringent non-functional requirements. Also, a lot of attention is put on network automation, the implementation of a long list of new workflows, including L3 VPN establishment with SLA, multi-layer topology discovery, service access control, ACL, service restoration, service location awareness, traffic engineering, slice SLA enforcement, slice grouping, forecasting, interdomain slice SLA enforcement, interdomain connectivity, provisioning, and SLA enforcement using DLT, and energy-aware network service placement. During the webinar, the TFS participants will introduce the highlights of the new TFS release, along with some demonstrations of the new capabilities and use cases that the TFS community has been working on during this cycle. The webinar is scheduled to last for up to 60 minutes and will be followed by a Q&A session should time allow. If you would like to ask a question, please click the Ask a Question button and type it in. Before handing over to Ricard, I'd like to remind you some of the quick points about our webinar today. The recording of this webinar will be available on demand a few minutes after we've ended it at the same location as where you are right now. Please feel free to ask questions by clicking the question button. We'll handle questions at the end of the webinar. If we don't answer your question at this time, don't worry, we'll get back to you after the webinar by email. The slides in PDF format have been provided in the attachment section so that you can download them. There are also links that you can also download too. Now, over to you, Ricard, to start the webinar.
So, thanks a lot, Gavin, for this introduction. Let me just present the speakers today. So, welcome everyone to this webinar, which we are presenting our proud ETSI release 2 for TeraFlow. The speakers today, it will be myself first introducing. I'm Ricard Vilalta from ETSI and the ETSI TeraFlowSDN chair. Then I will ask Oscar Gonzalez de Dios to speak. He's a senior researcher at Telefónica, and he's a member of our ETSI TeraFlowSDN Technical Steering Committee. Finally, we will have Luis Gifre from ETSI, who is the chair of the Technical Steering Committee, and he will be the one presenting the demo of TeraFlowSDN Release 2 and also the next steps for TeraFlowSDN. So before jumping into the different topics, let's show you the agenda. As I said, I will first introduce a little bit why we are doing this TeraFlowSDN, what's the need for yet another cloud-native SDN controller. Then we will have Oscar Gonzalez talking more on the Release 2 features and use cases. And finally, we will discover the features in a live demo. So let's start with the need for a cloud SDN controller. The question that some of you might ask is, do we need yet another SDN controller? And we think that it is very important. Of course, I do a spoiler, and I will answer you that yes, we do need another SDN controller, and we need an SDN controller that focuses on cloud native, is based on cloud native software, and focuses on the transport network requirements that are quite stringent for the networks. So we say that we need alignment with the telecom infrastructure project mass requirements. So where all the different operators are defining how do these SDN orchestrators or controller of controllers shall look like. They are also defining how different use cases need to be tackled. We focus on the IP over DWDM, for example. Our main scenario goes from the cell-side gateway up to the network core. So we are able to provide this transport of network packets. Of course, we need to focus on operator use cases using this open source approach, which is quite which by generating a global community, and we align the different community contributions. The main idea is that we have a brand new with state-of-the-art software techniques, transport SDN controller that provides these operator use cases. Finally, I would also like to remind that we are part of an European community at ETSI. Of course, it's also global, but we want to be compliant with European cybersecurity requirements. So that's also some of the important things that of the key messages of building yet another SDN controller. I thought that this has helped you understand that this need, and maybe now I will spend a couple of minutes only, but very important to detail the different benefits and challenges of using a cloud-native SDN controller. So when we focus on the cloud-native approach of software development, we see that we typically build monolithical software into small pieces of software, which are called microservices that are able to interact between them. And this provides a lot of benefits, but also different challenges. TeraFlowSDN focuses on maximizing the benefits. So we provide a resilient SDN controller, which is able to self-heal the different internal components. It's with this microservice approach, we can have auto-scaling. So imagine, for example, that we have a path computation element that is doing path computations, and they take a lot of. It can be scaled horizontally, not only vertically, so that different computations take place in different microservices, that instances that are deployed on demand depending on the workload. This allows this auto-scaling and reduces the latency for providing new connectivity services, for example. Also important is the load balancing, so that if we have also a rush of new requests, connectivity service requests, we can easily jump between them and deploy new instances of the different components to tackle that load. Then, of course, we can scale down when the load is over. This approach of software development also brings some challenges, and it's something that we are tackling also in TeraFlowSDN. So this means that we require more support for versioning of the different microservices, and they involve protocol buffers that interact between them. Also, we need more. There are more challenges in building these microservices, deploying them, testing them, monitoring them, logging, debugging, and providing different connectivity. So why TeraFlow is important, and ETSI is giving us support. So TeraFlowSDN in ETSI is a toolbox for quick prototyping, experimenting, and validating new use cases and allowing different ETSI groups to work on future network technologies to accelerate and improve the quality of the standardization cycles. It is also a bridge between the ETSI and the European research projects, as the code is adopted by other projects and new contributors arrive, and it's a way to have a significant impact among the different research projects. Then it's also a vehicle to promote and facilitate adoption of ETSI standards among software development communities and open projects. If we take a look and consider the different ETSI ISGs that have touch points with TeraFlowSDN, you can observe how we have analyzed the different environment and we have identified the different touch points. So, for example, if we consider the ETSI NFB ISG, we have a touch point, the one infrastructure manager. This is the place for TeraFlowSDN to play a role. In ETSI ISG MEC, the ETSI TeraFlowSDN could play a role in the federation manager. Also, in the ZSM model, we are analyzing the role of TeraFlowSDN in the transport network and cross-domain automation. ENI, it allows also to, and has touch point with TeraFlowSDN with the different dynamic monitoring mechanisms or some forecasting techniques that we are developing in TeraFlowSDN. A smart contract applicability, as you will see with DLT, applied to network management, is a touch point with the PDL working group. Then we also have the wireless transport profile and the backhaul automation, ISG, millimeter wave technologies working group. It is very significant the role that TeraFlowSDN plays there, as we are also interfacing with microwave technologies. Finally, also the last touch point is the resilient machine learning components for adversarial attacks and AI protection patterns that we are developing inside TeraFlowSDN, and that are touch point with the ISG SAI, Securing AI working group. The last but the most significant one is the relationship between OSM and TeraFlowSDN. So we can say that we are now presenting a full suite of an NFB SDN stack from ETSI. And that's something that's very significant. They are both related, they are both interacting together, and we have completed the integration between them. TeraFlowSDN, this slide is who are we, the different members and participants, which are the non-ETSI members. It's outdated because every week we have some new incorporation, but you can observe that we are a growing community with different interests, and here we need to align the different topics. So you are more than welcome to join our community, and then at the end of this talk, you will have all the details. This is the architecture. You can see here the different microservices architecture. I will not go into detail to explain all the different microservices, but as you can see, we have been integrated with OSM, and we also provide northbound interface, southbound interface, northbound interface to distribute different slices, transport network slices, to provide layer 2, layer 3 VPN services. On the southbound, excuse me, on the southbound, we provide support for OpenConfig white boxes. We have tested our OpenConfig implementation against Infinera and ARPA white box routers. And we also provide interaction with the MWT setup SDN controller. We are also providing full support for P4 routers in order to deploy there and control the different P4 programs there. And for the optical layer, we provide support for the SBI as to use the ONF transport API. This is how this looks like, and we are also providing support with the integration of an IPM manager for XR optics. This is the features for the southbound interface. Then you can see the different microservices which can scale up and down, and we're providing the context is where we have the state of the TeraFlow controller, and we have all the information regarding all the components, all the different control network equipments, and the different deployed services. Just this slide as a reminder for the OSM TFS integration. So you can see the demo and observe how we have integrated both worlds. So we have a full stack of NFV-SDN software. Now I will jump over to Oscar González de Dios from Telefónica, who is the member of the ETSI TeraFlowSDN TSC, and he will talk us about the list of features and use cases. So thank you, Oscar.
Thank you very much, Ricard. So now we are going to do a quick overview of the features that you can find in the second release of the TeraFlowSDN controller. So first of all, I'd like to talk about the context component. So this is our, let's say, central key piece, because it's where all the information about the network configuration is stored. Okay, so this is where the topology of the network, the different configuration that we have of the devices, the information about the links, etc. So this is the cornerstone, and it's optimized to have a concurrent access to all the information there. Then we have also the other, let's say, it's rebranded component. Okay, so it's the NBI component. So we know that we need to, from the controller, interact with the rest of the world. Okay, so we are gonna interact. It can be with planning tool, with other operation support systems tool or BSS tools. Okay, so this is why we have this northbound interface component. Okay, so this can receive service requests. Okay, so for example, two of the common services are layer 2 VPN services or transport slices. Okay, so these are the two services that we are considering now, but this is expanding. Okay, so they receive the customer request. Okay, then we have also internally a service component. Okay, which is provides a network view of the service, and this network view of the service, we can use it to interacting with the drivers to really deploy the service. Okay, so this is the decomposition of the service into device-specific orders. Okay, so we have developed a driver application programming interface. There is a new API to facilitate this work of interaction with the SBI components. Okay, and which is the support that we have right now? So on the one hand, we are supporting any router that has OpenConfig-based YAML models that exposes them via netconf, and also we are able to talk with optical network. In this case, the choose, instead of talking directly to the devices, talk to optical controllers through ONF Transport API. The same thing with microwave devices. So here we are able to talk with the ITF topology model with microwave enhancement in order to be able to request connectivity between two microwave devices. Also, we have incorporated recently the support for a new technology from Infinera, the XR optics, the point-to-multipoint, and we are also able to control such point-to-multipoint devices. And finally, as already mentioned by Ricard, and it was one of the calls from the very beginning, is the support of P4. Okay, we'll have a slide later where we can talk a little bit more, but basically it's just pushing, be able to push the runtime of P4 and to be able to interact with this P4. So as mentioned, one of the first goals that we have is really to produce a controller that is able to work with real devices. Okay, so our first goal is to use a standard. Okay, so we choose OpenConfig for that one. So any network operating system that works with OpenConfig is liable to use. And here we started to select a couple of use cases to provision layer 2 VPNs and layer 3 VPNs. Okay, so we created a workflow to work with them, and we tested it. First, we started with Infinera boxes, and then we moved to Adva Deno software that runs in the testbed that we have in, for example, Telefonica. We have checked it with the Adva over Edge core devices. Just know this is what we have validated. Okay, we are currently extending it also to be able to support to do it multi-vendor. So please expect to be ready with tested with multiple vendors for the next release. So here, stay tuned, guys. Then the other functionality that is incorporated into this release is the support of P4. So here, as the outcome of the P4 file, so we have a couple of files. One of them is the binary file. Okay, that it is let's say what really goes on to really tells the ASIC to do the pipeline. Okay, and that is downloaded to the device. And on the information part is goes to the TeraFlow controller, where what we are doing, or let's say the development in the TeraFlow controller, is to be able to talk between the device and TeraFlow controller through a gRPC interface. Okay, so we can manage the different match action pipelines that are specified in the program. Okay, so with this interface, this communication is in case. Then what are the other functionalities that we have also? So first of all, we have the validation of SLAs. Okay, so here, for example, for the slice component, for the service component, we can define a set of SLAs, and based on monitoring different KPIs, we can determine whether such KPI is violated or not. So also we have added the support for slice grouping in this feature, and also we have now a new version of the path computation component. So you can add your algorithms here. Okay, so here in this version we have already included a set of algorithms. Okay, so just to know this. This is a library, okay, to path computation that work over the information that is stored in the context component. Okay, so in the context component is where we have all the topology. Okay, and here we have here a sample of algorithms. Also, if you want to contribute, okay, here this is a very good place to include your algorithms here. Also, we have the automation component, okay, where you can define for the automation this event condition action loops. Okay, so you detect, you can monitor something happening in the network, and when that happens, okay, trigger a set of actions either through the different SBI components that we have, so you can decide what to do in the device. Also, the monitoring, here you have a good monitoring capability in the project. It was also one of the key features, and we are continuously expanding these monitoring capabilities, and is the ability to monitor metrics from the different equipment and store those metrics and create and select KPIs from them. Okay, so we are working also in adding this also the stream telemetry capabilities to the component. Also, as we mentioned, internally all the components within TeraFlow they use gRPC to communicate between all the components. However, okay, sometimes, as we reckon, we need to interact with the rest of the world. Okay, so here we are also following the recommendations also from the industry and following the most mature standards, and it is the use of REST follow a REST interface. So specifically, we try to accommodate to REST conf specifically because we are usually using mainly most of the elements are also described in Django, so we can interact with the rest of the world using these well-known REST interfaces. In addition to interacting via API, okay, which is very, let's say, comfortable, okay, for interacting with the third-party elements, okay, and can integrate in, as we will see later in most of the orchestration architectures today. We also have a GUI that we can interact and we can use it to as a mechanism to make the different calls that we have available in the TeraFlow controller. Also, we can inspect what is the network state, we can make requests, etc. So that this GUI is at the beginning very useful for us also for development purposes. I guess that depending on your use case, you will end up using more the APIs rather than going to the GUI. But at the beginning, I think it's very, very useful to have this component. Also, we have incorporated in this one very nice couple of very nice use cases. So the first one is related to cybersecurity. So here we can detect in the traffic of the monitoring the traffic of the VPN and detect if there is some malware doing crypto mining. Okay, so you detect that you are being crypto mined, and based on the detection, we are able to create specific rules to mitigate that attack and select which is the traffic that needs to be blocked, and we are able to download that using the service ACL, and in the end we end up doing OpenConfig-based ACLs in the device and effectively blocking the traffic. So we can do the detection and the mitigation. Also, we are doing very advanced interdomain techniques. Okay, so here we are also we have a demonstration now very soon about that using the distributed ledger technology that interacts with the interdomain component. So here, what we can do is provision paths in different segments of the network, and to be able to authenticate, log all the different steps that we are doing. So basically, here what we are doing is enabling the whole network automation into the transport network. Okay, so here this is in this picture I show you which is the current state of the demonstration that we are doing at Telefónica premises. So here in Telefónica premises we built a set of multi-technology devices. Okay, so we combined all the technologies together. So we put different IPMPLS white boxes that run netconf Django with OpenConfig and are controlled by TeraFlow. We have a microwave link that is also controlled by TeraFlow. We have also a set of optical devices control a line system that is controlled by Transport API from the TeraFlow controller. So all of that together comes into TeraFlowSDN. So you can create new workflows, automate all of this. So we have developed the foundations of very nice automation in the transport. As we mentioned, and this stay tuned because we have a demonstration in NetSoft about this, is the interdomain where we have two different SDN controllers talking to each other. We are able to do multi-domain path computation, so we can select which is the path, and also we can, as mentioned, authenticate the different steps. here. Also mentioned before, the network security. I think this is one of the key features that we are incorporating here. Have the capability to use TeraFlowSDN to detect and mitigate the software attacks. Yes, I think this is you already have in the current release. You already have those capabilities. Also, you can create your own security detection algorithms, and you can reuse the mitigation the mitigation capabilities that are already present there at the TeraFlowSDN controllers. Okay, so feel free to start downloading and testing it. And just finally, a few words. Okay, as we mentioned at the very beginning, one of the key components that we have been working with is the slice controller. Okay, so here we are able to receive from TeraFlowSDN transport network slice request. So in the beyond 5G orchestration, it can play the role of the subsystem to manage the slices. So here, this is the component that is receiving a lot of attention today. It is being aligned with the work also that is done not only through GBP, but also in IETF. So we have done a whole coordination work to ensure that TeraFlowSDN is able to provision IETF-like slices, and that those slices can be translated properly then into the network. So we think it's a very important piece. So with this, that we have done I hope a good overview of the capabilities of the TeraFlowSDN controller. It is now that time that you can see them in action. Okay, so in order to see them in action, I will leave the word to Luis, who will be showing you what our TeraFlowSDN controller does in reality. So please, Luis.
Thank you, Oscar. And well, let's go with the demonstration. First of all, I think it's important to show you or to give you which is the main entry point in case you want to play with TeraFlowSDN. You have here the link to our website. It's tfs.etsi.org. And there you can find all the important links, including requisites, guides and walkthroughs, tutorials, virtual machines, the Git repository for the controller, and also the contact details. Besides that, in case you are interested in deploying the TeraFlowSDN controller, it's worth noting that, for sure you need to fulfill some requirements we think are not so stringent requirements. At the end, it means what you need is a platform able to run microservices. In particular, we are focused on Kubernetes-based environments. And for development and small demonstration purposes, we rely on microKates, in particular version 1.24, because it brings huge simplicity in deploying a Kubernetes environment, managing everything, and so on. The hardware that you need to run the controller, it's just a classical Ubuntu operating system. In particular, we tested it with 20.04 and 22.04, the last two LTS versions. And well, you can choose server or development environment as you prefer. Then you need to run the virtual machine or the host with four CPUs, 4 cores. If it's a VM, we will suggest to use 100% execution capacity for best performance. At minimum, you need 8 gigs of RAM and 40 gigs of storage in your disk, but we recommend 16 because it's better in case you are doing development. You need to regenerate Docker images and so on. Besides that, well, we provide a pre-built virtual machine with everything installed. It's a matter of simplifying your life and preventing to repeat boring operations. So you can download the virtual machine from the website and the GitLab repository. If you are interested in deploying it by yourself, because, for instance, you need particular settings, whatever, you have all the steps documented in the wiki page within the repository. You have here the 2 links. And for sure, we try to be generic enough, but if you need some help or you find some trouble, feel free to contact us through the Slack channels. You will find the links later. Then let's go for the demonstration, and for that I will first share my screen. So give me 1 second. I will be using this same set of slides for the demonstration, but I will show them on my screen because I will need to start jumping from the slides to the virtual machine. First of all, well, here are the slides. You can find them in the it's the annex to this slide deck. Also, I have here a virtual machine. It's the one that you can download from the website and the repository. And here I have VS Code open. I will be using it for throwing the different commands. And I also have here, well, it's from a previous execution, the interface. We will redeploy and show you how it works. First of all, I will start running the deployment because it could take a few seconds, so we will save time. And I will explain what I'm doing in a moment. So I deploy, and now I will explain you what I'm doing. So to deploy the TeraFlowSDN controller, well, you need to install microcaches with some add-ons. You have the details again in the wiki page. This step is done in the virtual machine already, so don't worry. You need to start the microcaches and well, check that everything is up and running. If it's not running for whatever reason, you can throw this command to start it. Next, well, you need to check that everything is done. For that, you can use these 2 commands that periodically, every second, inspect the status of microcaches, and when everything is active in terms of add-ons, then you can run the second command. This one will check that all the different pods are up and running, in particular the system pods, because we haven't deployed the TeraFlow. Next step is to configure the deployment. For that, we provide means for configuring the specifications on the TeraFlow. All the details on how to configure it are described here in this link, in the deployment guide, in particular section deploy TeraFlowSDN. It is done by means of a script that contains a set of environment variables for configuring the different elements. In particular, it has 4 sections. One of them is the TeraFlowSDN directly related settings. And then we have 3 additional blocks or sections for the Cockroach database, which is the distributed relational database used by the context component in the backend. For the NATS, that is the lightweight and distributed message broker, again used internally by the context component. and the QuestDB, which is a time series database that is the backend used by the monitoring component. For this demonstration, I will not cover these last three sections because changing the settings for these sections is considered as only for advanced setups. So, but in case you need to change something, feel free again to contact us through Slack, and we can explain more in more detail what and how to do it. Next step is describing a bit the important settings for the TeraFlow SDN section. In particular, we have here one setting that is specific for setting where to store the Docker images, the list of components to be configured, also the image tags and namespaces where to deploy. You can configure some extra manifests that you can use for that you can apply during the deployment. And in particular, we use this feature for activating Nginx-based ingress controller that exposes from a single point the web UI, Grafana, and so on. Grafana admin password in case you are using the monitoring component. And we have flags for skipping the rebuild of the images that is particularly useful for demonstrations because it prevents investing time in rebuilding everything. After that, you see the command I was throwing, which consists in sourcing this set of settings and then running the deploy all script that will deploy the TeraFlowSDN controller. What this script does is deploy first the Cockroach database, then the NATs, then the QuestDB, and finally the TeraFlow. It can take some minutes, that's why I did it beforehand, and then I jumped to explain everything. And while the script is running, you will see the different steps that are being implemented. You will see the details of first the three dependencies, later the microservice deployment itself, and at the end, you will see the final report. And you can reproduce the report using this deploy show sh command. Now let's go to the virtual machine. You see here that everything went fine. You can check the details and so on. And after that, if we jump to the virtual machine, to the browser, we go home. Okay, we just refreshed. Everything is up and running. We have nothing deployed. So the first thing we will do is to create a context and the topology for our experiment. This can be done by means of descriptor files. These are JSON files where you specify what you want to deploy, and it supports up to now the creation of context, topologies. You will see later devices, links, services, slices, and so on. So in general, if you are playing manually with TeraFlow, it's as easy as choosing the appropriate file. I showed you the file, submit. Okay, it created the context and the topology. So now here we can select the context and topology. Up to now it's empty. What I will do now is to start a number of components, in particular Transport API server emulator. I will start also for netconf openconfig based device emulators for this experiment. 3 and 4. Okay, and now we should have everything up and running. Okay, next step is to onboard the devices. To do that, we do it through the descriptor files. I will not go through all the details because it might take quite a lot of time. I prefer to directly upload the descriptors, and I will do it from the web UI with one file that I already have with all the devices. So submit. It will take a couple of seconds, and it identified the 5 devices. I will also onboard the links. We will connect these devices just to be faster. Now we have the devices in the onboarded with TeraFlow discovered the different endpoints, the tapes, it enabled them. It discovered pre-configured and created appropriate configuration rules. And same for the links. So now what I will do is first create a layer 3 VPN service. So I select the descriptor, submit, a couple of seconds, and okay, so now the service is created. We can go to the service section, and you can see that it created 2 different services. The layer 3 service is the one that we request, and the SDN controller was able to detect that to go from router 1 to router 3, it had to pass through the open line system. And for that reason, it created the connection, but with a subservice. This subservice is the transport API one for the optical layer. So if we go back to the list of services, we have the transport connectivity service with the 2 connected endpoints and with all the details. Okay, so we can now go back in case we want to delete, for instance, the layer 2. And we can also check here in the device the list of configured rules. You can see here that these are it's a representation of the OpenConfig rules, and this information is then used to compose the OpenConfig templates that are sent to the devices. Okay, so now let's remove the service, this one, and we will do the second experiment. Okay, it's deleting. Okay, so now we have no services. I will explain briefly the second experiment. In this one, we will demonstrate interaction between open source Mano and TeraFlowSDN. For that, what we will be using is not the entire open source Mano because it will be huge for a single virtual machine. What we will use is a specific tool that we developed, simple tool, that we name it as mock OSM, is a tool that takes part of the code from OSM, in particular the one used for interacting, well, for issuing the one infrastructure management request, and it enables us to send exactly the same command that OSM would send if it was running, but without the complete overload. So for that, this tool exposes few commands, so create, delete, and status. We will issue now the create command. And this command, what it will do is to first contact with the TeraFlowSDN controller, request to create a slice. In this case, it's 2704 slice. If now we go to the browser and we go to slice, you see 2704 slice was created connecting router 1 and router 4. If we inspect the details of this slice, we can see some constraints specifying the location of each of the routers, some particular details of the different devices that needs to be connected on the border, and which is the service that supports this slice. In this case, it's just one. It's service 2704. We can go now to service, and we have service 2704. In this case, is a layer 2 service connecting router 1 and router 4. I will not go through all the details of showing the details of the services and the underlying transport connectivity services for the sake of time. What I will do now is just show you that you can check the status of the service. It's active, and well, you can delete the service. In a couple of seconds, it should be done. And now if we go back to slice, the slice went away, and the same for the services. And well, that concludes the part of the demonstration. You have the additional details on the slides. We can jump back now to the slide deck. And well, just to explain, if you want to learn more, the idea is, as said, that TeraFlowSDN controller comes from a 5G PPP project named as TeraFlow, and it bridges and enables the opportunity for 6G SNS projects, like, for instance, it's planned to be used in scale, across, and so on, and a number of projects to use this novel SDN controller, its capability of interacting with open source manual NLP orchestrator. And well, if you want to contribute and provide additional features, you are free to contact us. You have here all the links in case you want additional information. We have a Slack channel that is very active in case you need some help. It's probably the main starting point for contacting. Stay tuned with all the mailing lists that we have. And for sure, if you want to see additional demonstrations of TeraFlow, join follow us in Twitter and LinkedIn, because we are publishing there all the experiments, demonstrations that we are doing. And well, last but not least, TeraFlow, as we said, it's open. So if you want to join, if you are interested in participating, you have here the details for joining. I mean, you can join in different ways, as individual contributor or as a member or participant with the appropriate agreements. Then just create your account, and if you have any question or you need some help, feel free to contact us through the mailing list. And well, that's all from my side.
Okay, thanks a lot, Luis. So I hope that you have enjoyed these presentations and the demo. I don't see any question yet. So meanwhile, you are warning and preparing your questions. Remember that you can post them on the tool, on the question mark tool. Maybe now let me change this so we see all the faces together. Please try to provide your questions, and we will try to provide your answers. Meanwhile, I'll have a couple of questions for Oscar and for Luis to warm up a little bit before taking yours. So, Oscar, you have been presenting the different use cases for TeraFlowSDN. Why do you think TeraFlowSDN provides value to the operator?
Well, first of all, today we had really no proper SDN controller adapted to current times. We only had almost open daylight. This is what we had. And as you see, there was, let's say, they were lacking many functionalities that we had today. We have we had been working a lot within ETSI, as you know, with OSM. It was a great success having that for the orchestration part. So for the SDN control part, we required an open source SDN controller that was cloud native and could be used to develop use cases and foster the industry. We hope that the industry also can catch up. Now this is just starting, okay? But the number of use cases that we have around SDN control is huge. I mean, now it's the key for us to build future networks. If you see also, there are some initiatives around, like Telecom Infra Project, Mass Group, that is defining use cases that must be fulfilled by SDN controllers. So we see that there is a whole room for this for an open source SDN controller. Okay, so we hope that we can create momentum, we can get more people in the community, and that we also move from prototype phases also to releases when some companies can take it and can productize it and can deploy it in our networks.
Thanks a lot, Oscar. So I see a couple of questions. I will just throw it to you, Luis. Maybe the first one. The PCE was refactored in release 2. Do you have any scale expectations of the PCE design?
Yes. Well, briefly, the PCE, it's based on a front-end, back-end scheme. That means the front-end is in charge of interacting with the TeraFlow components, while the back-end is implemented in C++ for high performance. The idea is that this component can be automatically self-scaled because it offers in front of it load balancer. That means whenever the platform detects a huge load, it can deploy additional replicas of the component, and well, it scales up to the amount of resources you provide in your Kubernetes environment.
Okay, so thanks a lot, Luis, for the answer.
No.
So I think that was very clear. And the second question we have, it's quite technical on the P4 support. I don't know if you will be able to answer, Luis, but let me throw it to you. If not, we will come back to you later on. So I will leave it as open. Does TeraFlowSDN support regarding reading and writing P4 registers? Which P4 targets have you tested? My guess is that the second question we have we need to ask our colleagues from UBTech.
Well, I can answer half of it.
Oh, okay, let's try.
Yes, because the P4 target, if I'm not wrong, the one that is tested is Intel-based. I mean the Tofino switches. I'm not sure about the first one, about reading, writing P4 registers. That part probably needs an answer from UBTech.
I think it's part of the slides. So if you take a look at the slides, it's part of the process that we have that Oscar presented. So I support that. I think that it refers this question to the support of writing a P4 program into the Tofino switch. I think that in this case the answer is yes. We provide the full life cycle for the P4. I will leave it
as in this case. I confirm.
Yeah.
I can confirm that it offloads the bit stream into the device, and well, for sure then it's focused on Tofino switch, Tofino boxes.
Okay, so thanks a lot for both questions. I will throw a question to Luis. Meanwhile, if you have some other burning questions, remember you can write them here, or you can write us an email afterwards if you are interested to have a more intense discussion with us. So Luis, which are the features that you expect for release 3? You know that we have a release cycle of one release per year. So we are now currently planning release 3. What do you expect to see there?
Yes, for that, well, for sure, one of the obvious features is to continue evolving the support we provide for different vendor equipment. We want to test or solve one interfaces with other vendors because it's well known that different vendors have different implementations. Also, we want to continue extending the northbound interface with additional interfaces. It's planned, for instance, Transport API. It's also planned to extend and provide deeper support for IETF slice MBI, for instance, layer 2 and layer 3 VPN. And besides that, also there is plan for integrating a BGP speaker for automatic discovery of the network devices. And well, these are some of the main features for sure. Then the rest of components, we have many enhancements and new features that are listed in the GitLab repository. It's open, so you can just visit the repository and check which are the ongoing implementations that we are carrying on. And for sure, if you want to propose or request new features, that's also the place to go.
Okay. So regarding the first question, I also had some support from the people from UBTech. They asked me, they have answered me that the driver supports setting and deleting entries for regular tables, counters, direct counters, meters, direct meters, action groups, and action members. They have already been tested, and maybe it's not complete, the list. We tested on CPU-based targets, mainly on the B2, B4 switch. So this is the technical answer for that. So thanks, Luis, for regarding that overview of possible features that will be part of release 3. That's something important. We have also another question regarding the support for P4 packets in. Do you plan to abstract the P4 pipeline while providing high-level construct for SDN applications, like for instance ONODAS? For example, how can you write a pipeline agnostic application in TeraFlowSDN? That's something that I can answer myself, as I have support for the question from UBTech. Packet in and out is supported by the driver, but the device component has no means to exploit it, as it is not part of the driver API. So none of the device drivers support this concept. So we still are far away of this pipeline agnostic application. We focus more on the service component to have their a dedicated plugin that makes use of the driver pipeline. That's something that we already support in this release. So that's how we handle this. That's a tricky question. I don't like to answer, but because it's quite impolite, I think. But we will provide our best. What is the advantage of using this SDN controller in comparison to ONOS, for example? So let me just give a first answer, and maybe Luis or Oscar, you can detail later. But our main interest is in this case, and the main advantage of using this SDN controller is to foster innovation in transport networks. In this sense, we think that the new features that we are presenting for transport networks, so if we focus on how on this network segment, that's we provide great benefits. We also provide interesting support for OpenConfig white boxes. We have presented some of the different things that make our controller unique. So it's not like, okay, what are we doing right and what ONOS is doing wrong, but which are the use cases that we support that were not supported before in the community. So I think that, Oscar, you have also talked about this. Maybe you can comment a little bit more.
For example, one of the things I really like about TeraFlow is the cloud native, and I think that's also one of the key difference, the way the internal structure. Of course, it is some functionalities are not yet as mature as in ONOS. I mean, for example, in ONOS there are some functionalities that have been running for many years. Okay, so in any case, here our approach was somehow a little bit different. Okay, let's try to do a new approach to build the controller and start building on top of it. So it will take, of course, some time to catch up with. If you go to a very specific detailed functionality, it will still take some time to catch up. Other new functionalities, for example, as Ricard mentioned, the OpenConfig part. I mean, that's brand new here than in TeraFlow controller. Okay. So right now is, I think, the internal architecture and the way of doing the scale up that we think is the way to go.
Thanks, Oscar. So I would like to conclude with this last not question. Thanks, Ricard, Luis, and Oscar for your work and innovation. So thank you very much also to the audience and all the TFS community that has ensured this second release. We want you to be part of this. So either you are users or you want to consume TeraFlowSDN or you want to improve TeraFlowSDN, you will be more than welcome in our community. So I will close now the webinar. So thanks, Gavin, to the technical support from ETSI, and hope to see you soon in the next meetings that we will be handling in TeraFlowSDN.
Okay, thank you very much, Ricard. I'd like to thank everyone who's been listening, and also to thank again our three presenters for producing this webinar. Please keep an eye on the ETSI Bright Talk channel as we're making webinars on a regular basis. And so once again, thank you and goodbye.
Thank you. Bye-bye.
Bye-bye.
Bye-bye. Thank you.